students of ELSCB, welcome to the classroom of the Knowledge Center. And hope you all remembering this is a day 2, and we are much more excited to have a session like this. And I'm privileged to take a class on this day. First class has gone up with our Ramanathan has covered up the heated section battery. So the sections are handling very big items. The contents which has to be covered in a shorter period will be much more bigger. But anyhow, this is being an introduction. We all will be cherishing our knowledge in upcoming days with the day-to-day classes over here. And right now, our seniors are also awaited, and being a first bench seater of a student is most excited to see you all in the same place. So let us begin with the presentation today. This is the topic which is given to me is the measurements of the three-phase traction motor. Three-phase measurements means it is a basic thing which we all cover in our schools and colleges sessions. Measurement is the basic. Basic things is the measurement we have to learn from the start from the right to the scale. The school level is scale, and this is the basic measurement. And upon in this engineering level, there are many more measurements evolved, and we will be seeing one by one in the three-phase traction motor. Just I would like to have a glance of an introduction about our traction motor. This is we call it as a three-phase traction motor, and the model of the three-phase traction motor is 6FRA6068. This particular traction motor model has been designed to work in two types of locomotive in our railways. Right now, our train is having a W87 and W89. This one traction motor can serve these two locomotives. This being a basic thing, I would like to the simplification. The smallest change in the field of working from this to this is the pinion. The pinion right now it is fitted. What is shown in this figure is the W89 pinion, because it is 21T pinion. This pinion will have 21T. When it is fitted 21T, this motor can work in W89. When the same motor is fitted with 20T, this motor is eligible to work in W87. That's all the small difference with this traction motor. A small and quick introduction. Measurements of three-phase traction motor are essential for optimal performance and reliability. Understanding various parameters helps ensure the motor meets design specification and operate efficiently in demanding environments. The demanding environments, we all knowing, our motor is not confined to a particular place. It is supposed to run right from the south to the north, and various climatic conditions and various speeds and different loads. These are all the demanding environments. So this presentation covers various measurements focusing on electrical and mechanical aspects that define the motor performance. Here I would like to once again insist there are measurements cover electrical as well as mechanical aspects. In this session we can cover one by one with this electrical session and later on to the mechanical session. This is what an constructional picture. We can simulate it to an MRI scan of our whole body, because our body is composed of things. When it is scanned only, we can able to see the internal part. As like that, this is a scanned object. What is what inside the traction motor when it is stretched like this. So you can see from the right count of the serial number 1, 2, 3, and many other components are written in the right. The 15th one. So we can conclude that there are almost 15 major equipments and minor equipments are combined and assembled in this manner and makes one complete traction motor. These names may not be familiar with other sections who are working, but few people will be there. You know, just I will read out the stator core and the shaft. Shaft is a main thing. This is the shaft. The rotor core, rotor bars. This one. Then SC structure gateway and resistance rings. These items. This is coming from this question. Mechanical locking plate. These are all other outer locking any different. So these things are available in the next slides also. We can just move on to the next slides. Can we move next? This is what? That's what the photographic scan. What we are seeing right now, this is similar replica of that previous slide only. But here, the real images have been kept aligned in the order, so that it will be easy for a new person who is coming into the section or whoever, we are in other sections, so when we come across the shop floor, we can also see through how the motor has been designed. This has been recently made ready because we have been maintaining features for years together, but this one such design has been made and it was recently innovated also. So it really gives a good outlook of what is what. Whenever a doubt comes, we can come and cross check what is what in this. So the same thing is previous slide is lying here. The components is the real thing you can directly explore after the classes also. Whenever things doubts arise, you can go through and learn from this exploded things also. These treatment details are in details with the other upcoming slides. First, as said earlier, we can go with the electrical measurements. Electrical measurements come already. We know electrical means voltage, current, resistance, and additional parts of inductance and power consumption in traction motor. These are all the values we have to go evaluate in our maintenance time. These parameters are crucial for assessing motor efficiency and diagnosis of electrical faults. Electrical fault diagnosis, because based on these measurements only we can able to diagnose certain other electrical faults and predictive mechanisms we can have it. And accurate measurement ensures compliance with operational standards and helps optimize energy usage. Compliance of all the test results, very and accurate measurements are essential for the standards we have to maintain for the overall outline of electrical measurements. Here comes our main part. Now we can upcoming slides on this is the first slide. We can go about the parts inside the traction motor. What are the test measurements we have to apply for the components? This we can call it as a complete stator. The stator body. Inside this stator, these are the magnet frame like the structure. This part is core. This core is laminated core will be there like this throughout the length. And inside this only, the windings are get assembled to make a complete stator. To receive the three-phase from this three-terminal, three phases are getting inside and the windings are interconnected. In that way, circuit is getting closed. This is a small one segment of the winding. How the winding is getting inserted in the slot. The internal design structure of the winding and its insulation is mentioned over here. That is called between each and because copper connectors are there. Between two copper conductors, a Kapton film. Kapton film is used for insulating material. Kapton covered CE conductor. The conductors are CU, that is copper. The insulation provided over the conductor to avoid touching without contacting each other is the Kapton film. This is the construction view of the stator. Next slide you can see the test what are the things we have to do. Basically we know all well about the, in our field of experience, IR value. Insulation resistance is the prime thing. Everyone, not only PM, all other electrical sections who are dealing with electrical components will be doing this internal V is equal to IR. That's what our Ohm's law formula. Insulation resistance will be done. Insulation assess the healthiness of the electrical insulation of the stator winding. So higher insulation resistance indicate a good insulation condition. That's what whenever we do for measuring we used to say in our conventional way. When we get a higher insulation, that we obviously define that it is a good motor. So that is what the overall the simplified form of this insulation resistance is. Basically, we do the test for 1 minute of insulation and we will get a value. Okay, the particular motor is traction motor stator winding. We are keeping it ready with the insulation digital insulation tester available. There will be always three phase U, P, W will be visible in the terminal part. So, because these motors are high capacity, we can apply 2.5 kV of insulated resistance voltages. So we can, because of the procedure I would like to simply elaborate. Suppose if we touch with one point, it will be kept in the live part of the phase winding. The other part obviously we have to keep in the earth part of the stator board. So when we do this digital method, when we press it, the meter will start applying the voltage to the terminals. So across now, the voltage will be passing. A minimum 1 minute you have to maintain the voltage so that the insulation resistance and the starting time it may get increased, so we can feel it is a good IR value, but consistently it has to maintain in the same manner. So we have to wait at least for 1 minute. So that after the 1 minute, we have to take out the reading from that. So that will be the real reading of the insulation resistance. So 2.5 kV we apply for getting the value. Whenever we apply high voltage, the values of insulation resistance we get, if it is in gigaohms or megaohms, we will be getting. So next for higher value, the same. We can also apply 1 kV and check. When we apply 1 kV, obviously we are reducing the input voltage, test voltage to the 1 kV. So when we apply 1 kV, what we get earlier, definitely it has to get increased. So in that way, we have to get cross confirm with the two applied voltage of the insulation resistance test. So having a references of camera, the same only we are having, because we can mention it is very accurately mentioned 6.36 megawatts. So it is a minimal. This megaohm of insulation is available at 2.5 kV. This is ready to serve in a good condition. But whenever we get higher, it is more efficient for our reliable services. Next comes another electrical test is the inductance test. To detect winding contamination, air gap issues, rotor problems by measuring the magnetic properties of the winding. Here you can see, right now we are testing, this is all about the stator, we are testing applying, but here it is mentioned clearly rotor problems. Because rotor problem, which is in assembly condition, means a rotor will be inside this stator. So this is by means of this test, not only the stator winding issue, rotor issues also will be revealed by means of this induction test. So that's what for a running motor, running locomotive, schedule and all, this test is very, very essential, and we are not only following only in the overall, this test has to be compulsory done during the schedule also. During schedule, each 3-phase locomotives are being done with this inductance test. Next we will see the parameters of this. As per earlier for the previous stator, we have 3 terminals U, V, W. That will be the common exposed terminal for a stator winding. In that U and V, first if I am taking inductance meter to the traction motor, close to that, so I have to keep, previously in the insulation resistor, one terminal we will keep in the live part, another in the earth part. Here there is no related to the earth. For this test we have to keep both the probes U and V, one probe in U, another probe in the nearby winding terminal. So U, V. So I will be getting one reading, so that we have to know, like it will come 3.037 like that. So same procedure I have to repeat for V and W, W and V. So that we will be getting totally 3 readings. So what does the SPI 262 says? Whenever we get the 3 readings, we have to find the maximum and minimum of the 3 readings. Examples I didn't write here. When we get a 3 reading, we have to take one minimum and take one maximum. When we subtract, we will be getting a value. That value should be 0.010. Sorry, sir. 0.015 millihenry. 0.015 millihenry. It should be less than 0.015 millihenry. It says that the thing will be this okay. Right from 0.002 range onwards, we will be getting a new motors are coming. It is getting 0.002. So in that way, this is very helpful. Most of the motor changing cases are defined by only because of this test. This is the only electrical test that is revealing many kind of defects in the maintenance of 3-phase traction motor. Here this same procedure only. I have mentioned this and this too because, as I said earlier, this is applicable for stator fault also and rotor fault also. So when we repeat the test, when the stator is allowed, because in a not assembly condition, that time also we can find out the rule is applicable for 0.015. Even after assembling of motor also, this same 0.015 less than is applicable. So this test is a simple test anyone can do, and only the value precision, taking a precision reading, because we have to, as insulation tester also, we are allowing to insulation value to settle at 1 minute. In this also, because the values are in 0.000, the micron level of readings is being taken. So we have to precisely take a hold and wait and take one reading. If at all any doubt, we have to re-repeat the reading. Because 0.015, suppose if it is getting increased to 0.0, 1, 8 like that, 2 or 3 also, where we have to change the decision of motor change, make a decision of motor change. Any doubts in this session? Because inductance checkup may not be applicable for all other sections, auxiliary and I think even EPB coils also we are testing, sir. That is also we are testing. So simplify test only. Another test go for surge comparison test. Mostly for all auxiliary motors, surge comparison is a very mandatory test because some characteristics what we can see through. Applying high voltage first to each phase winding to generate a waveform. Whenever we apply a pulse, according to the applied voltages, a waveform will be generated. So to detect the main motto of this surge comparison is to detect internal winding turn to turn fault and shorted winding turn to turn fault, because earlier this same stator might have passed our insulation resistance tester earlier. Also it might have passed our inductance resistor maybe. Then when it comes to the finally this tester, there are chances the same stator may get failed, because whatever we do the test is our lesser voltages. Here we are giving a high voltage spike. So it is a high voltage will be applied. So it is how much it is capable of carrying the surges. So that is what the winding weakness, everything will be revealed in this test. So simple procedure is comparison of the resulting surge waveform across stages to identify the subtle defects before operation failure. So mainly it prevents unexpected failure due to its electrical stress. In this word it is mentioned as a stress. So how much motor has its own capacity to carry as a full load condition. The motor may work in a light load and a shorter period for lesser currents and lesser spikes. But when it comes for sometimes our atmosphere of rain working in the OHs and all, it is always supposed to get spikes at high voltages occasionally in the field. So at that momentary spikes also, the motor has to be designed and well to withstand this. So in that way, this test will reveal the withstanding ability of the stator and motor. This is the devices what we use for carrying out the surge test. The surge test device, surge comparison test. This is the top side picture. The applied voltage for the surge test is 5 kV. You have to apply a 5 kilowatt of supply to the winding terminals. As like in this inductance also we always compare two readings. Here also U phase and V phase. First it will be because there are 3 probes that will be always. You go to the previous slide. The 3 probes is the output of the surge connector device. Always the 3 probes will be permanently connected. It is always connected. While doing the test, automatically the rotor switch will select the U and V phase first. So when we give a supply, then there will be 2 waveforms will be generated and we can easily see through this oscilloscope. Now what we are seeing is one waveform here, but actually beneath backside of this there is also another waveform. One waveform belongs to U and another waveform belongs to V. The both is almost synchronized to each other and it is running in parallel. Through our eyes we can see it is only one waveform. There are different types of errors will be there, but whenever any internal issues of electrical research, the waveform will get slightly deeper. There are many other patterns of waveform differing is also there. So sometimes when we gradually increasing the surge voltage from 1 to 3, 2 kV itself, it will show some different. Sometimes at the end of the 5 kV or only the surge motor will show its defect. So there are the various defects will appear from by doing repeatedly. This test you will come to know what are the various different other waveforms. That is according to that. What is the real fault of the motor that also can be revealed. So this is one example I put it for the 2 waveform, that is one defect is lying there. So this data is not applicable for putting in the service. So similarly, UV once selected, then rotary switch to next, VW will be selected. At that time also the graph will be visible. This is also one simple test, but by carrying out this, there is a high voltage, has to be and the protection has to be taken care that the other end people should not come and That's the motor while we are doing the test. This is what the electrical test pertaining to the stator ending up with these things. Next comes to the rotor. What we are seeing is also a small photo picture only. The rotor is comprised of the structure of rotor stampings. Rotor stampings will right from here to here. The complete will be rotor stamping, laminated stamping. The bars are inserted into that. Each and every bar and finally attached to the entering resistance ring. This is the simplified structure. The rotor is in the center of the shaft is in the center of the rotor. That has to serve the other axis for creating the rotational motion. Shaft is the mechanical component. It is connected to the other thing. This is also subject to some small test. We see. Growler test. This is the one-on-one simplified test because we don't have any exposed electrical contacts for as like the Hitachi armature commutator. There is a portion called commutator where we can see the live parts. So another part is the winding part. That is insulated portions that we can't expose. Here there is no live part. So this test is mentioned if a coil is started. It has like a transformer second. Because right from the image you can see there is one primary. So it is kind of like so. Yes, short circuiting is happening by means of this growler test. Whenever a current passes, the current creates a magnetic field that causes the feeder to vibrate. Here it is mentioned the feeder because here you can see there is like a normal feeder gate kind of strip like that will be kept over here. So once we kept because the circulating magnetic field, when we insert the feeder, then we will get a field the vibration in that. So it will get the vibration. So it has to be dragged. This test has to be carried out from this end also to that end. Then it has to be placed here. The field has to vibrate in the middle, then at the end. The complete length of the bar, the vibrations we have to gradually glide it. We have to move the growler machine and we have to feel the vibration. When at one point of time, anywhere, when we doesn't feel the vibration means it shows that that particular that area because it's passing a circulating current, the bar has to be a little bit cracked. When it is cracked, it will not allow the circulating current to pass. So in a similar way, the rotor also, the feeder leaf also will not vibrate. This is a small and non-destructive effective test. By means of this also, many rotor bar cracks are being identified. This is especially scheme 2. That in the next classes we will try to cover up. There are different types of rotors available. Scheme 1, B1, B2, like that, 4 types of rotor. Because the structure and designs are changing. For a reliability measures only, now it finally comes to the scheme 2. Which little bit, scheme 2 is having certain other faults, rotor bar crack. These are all internally subject of 6 p.m. We will cover in the next classes. It's a simple test. When it comes to the mechanical measurements, I'd like to take a quick follow-up. Actually, we got for the preparation of class. I thought I got actually 1 day of Sunday to get together. Once we getting into this, we will come to know how vast is our subject. We want to cover. This is a point of TN section. But when I thought about all other movies are and that comes in mind. When I am hearing how the big C owner of the big C, how the sir is going to spend much time. But what I realized that when we are sitting in the front of a school, right, teacher will be here. So a crux only, finally a professor, our teacher will come and show. So preparing a sort of crux of formula and all, our teachers has taken more efforts and finally they are bringing a shorter way. So bringing a shorter way, really there are 2 advantages. When you are trying to present and prepare presentation and teaching, we are getting a refreshing of knowledge. And one way, we are getting a chance to refresh ourselves and it is an opportunity to make everybody enlightened. That's what is a real feel. Because I think Raghu has got the feel yesterday. Today I got, hopefully, at the end of the 13th day, all of our will get the same field. Because these fields will be applicable only for persons who are working as teachers in zonal training schools and everything. Always we are the listener over. Till now, you will be go for representatives and sit and learn and take notes. And this is the first time we are coming forward for this class. So very soon, all will be able to teachers. Here comes the mechanical measurements. This includes, as we are seeing in the earlier pictures, the shaft diameters, frames, and components inner core with its interference. This is the main criteria of interference. Mainly, this is a common and regular familiar word for us. This interference is a very vital matter for all the measurements in the station. The mechanical measurements, it ensures the motor fits within the system constraint and operates smoothly without excessive vibration or wear. All measurements has to be made precise. Already it is defined precise. When we maintain the same precise of measurement including our assembly, it is guaranteed that the motor will be run without wear and vibration. The precise dimensional measurement is durability and performance under various load conditions. As I said earlier, various load conditions, the measurements only take care of those compensating those various load conditions. Have a glance of the measuring equipments, measuring instruments. These are all the important. This is a filler gauge we are used to check for radial clearances and minor gaps and everything. Then there is a bore gauge. Bore gauge we used to go for check the inner diameter of any bores what we use in the taxonomy. Then micrometer. This is kept for the outer diameters of shaft and all other outer meters. Then here the basic tool and the dial gauge. This is certain other micron level movements are really sensitive only to the dial gauge for radial clearance aspect to use. Then it is a depth gauge, which are vernier cannot go and access. This depth gauge will take out the result and view. These are the essential tools we are using for the taxonomy classification. Here, directly I am coming to the main subject, main part. Three main measurement area of drive and rotor. The three main. All are main, even though these three main why we have mentioned, this is the area which concerns a lot and we have to concentrate a lot during our complete period of motor assembly. Just to see through, they will just go for a the design of rotor, especially for this three-phase traction motor, normally what is normally we can imagine a rotor means winding will be a part, a shaft will be the protected portion. Both the shaft will be solid. Here in three-phase, the drive and rotor, as we see the picture says, seems to be solid shaft, but later you can see, you just imagine it is a hollow shaft. The hollow shaft in the sense, the pinion is plugged into the hollow shaft. That is the way finally the pinion is plugged into, the pinion is holding inside the shaft and is getting a grip of that and it is mounted. In this pinion only, it is running for its entire service. Why? Because the inner line, I last time mentioned this, there are three components has to be mounted in this particular place alone. The first component we have to mount is inner lagging, and the second component is the inner riser, the seat. These are all the places where the component will get seated. The third component is outer lagging. It will get seated. Why I mentioned seat is that those components will get seated in this area. Earlier I noted now interference. Okay, the components will not, because assume everything is a cylindrical ring kind of components. Assume. Because those ring when we insert, it will automatically come and sit here. While fitting of those components, pinion will not be there. Okay? Like that. When we have to fit all the components over here, it's a ring. But where is the question of interference? Interference is this component dia should be higher. This OD, this outer dia should be higher. The component what we are inserting now, it should be lesser. So that's that time only we will get the essential grip. That's what, because suppose the outer component is also bigger there, then this is lesser means simply it will go. Then the pigment is not proper. So that way, because one way it has to be bigger. I will show in the next slide. These are all the components. These are all the ring kind of structures. This inner labyrinth will get seated in the first place. The middle place it is the it's inner place, and that is the outer labyrinth. These three components is where going to get seated in the shaft portions. These portions. I have simply tabulated a small the dimension of this. With this dimension itself, we can able to understand how the components have been made to get the interference. So first we will go for this inner labyrinth. Inner labyrinth, here shaft OD is mentioned as 184.050. Then other component, the component is going to seat over the inner labyrinth seat is this component. From itself we can see this is a bigger one and this is a lower one. So interference means that for getting seated into this, it has to expand and then has to fit. In that way, the components and its dimensions have been designed. This is for inner labyrinth. The minimum interference is given as 10 to 79. The bearing also, this particular shaft OD, inner is ID is given and 50 to 65 micron. Outer labyrinth also, the interference given as 60 to 150 micron. What I explained in this method, the hollow shaft is not visible. Here you can see from the front portion, the hollow, this is the pinion is not available. The shaft will be hollow in it. That is the pinion is having a taper. It's having a taper. This is having a shaft taper. That is a conical. So it seems to be horizontal. It is a conical in dimension. It is having a taperness towards it. So this pinion will get inserted into this. There are certain measurements and procedures for mounting these pinions also. So actually here it comes. What happens? The doubt should arise from all of you. What will happen in this procedure? When I take a pinion and I try to insert, I am pushing with a 1700 bar pressure is being pushed. There is a procedure for mounting pinion. When I push, it tends to expand. It's natural. It tends to expand. So what will happen in the earlier slide? When I am pushing, when the pinion is getting travel, then these dimensions will be getting expand. So here one expansion will happen, here one expansion, here one expansion will happen. So when to stop? I can go on pushing. That is a big range has been given. Here you have to maintain a 3 to 5 mm gap. That is a limitation. We can't go more and we can't go lesser than 3 to 5 is the debate criteria for a pinion to be getting inserted. So when I push at one point of time, then here comes the important role of the technician. What they have to do? They have to calculate the outer dimension, and to take the 3 reading continuously. By taking this 3 reading, this outer dimension should also come into this range. Then this outer dimension should come in this range, this range. If anything is get mismatched, then we can't go for shaft usage. So there are 3 important outer dimensions as per the tabulation. The pinion is at one point where we get all these outer dimensions are according to that column, then there we have to stop. That is the criteria is given for the assembly procedure. This is very vital and it has to be strictly followed. In that way, when it gets expand. Assume while taking this, there won't be any components over here. Then how comes here? This is the other. Here, what we have to do is we have to take the bore gauge and take the ID, inner dimension. This is also having, you have seen there, ID. This is also having this. This also comes in the same criteria. Then after getting this outer shaft OD and the other components ID, then our calculation comes here. We have to work out this interference, whether it is falling in this range is also. That is the third criteria. First we have to satisfy the OD, second we have to satisfy the ID, third we have to satisfy the interference. When all these, for all these 9 readings are satisfied and comes within a range, then only we have to say this pinion and rotor is okay for the proceed for the next assembly. These are very micron levels. Micron level. Why micron level important is it is subject to climatic conditions also. when we take the measurements of this reading at one room temperature of 32, when we take the shaft temperature and room temperature of 27, there will be mismatch. So we have to ensure that all the measuring object, measuring components, everything should be in the same atmospheric temperature. The measuring devices, instruments, that also should be in the same. Suddenly when I am taking a bore gauge or a micrometer outside from AC room and started measuring an object in the shop floor, then it will not give the correct reading. So the prime rule is all should be in the same atmospheric temperature. We have to wait, we have to allow them to settle, all to come in the same. For much more precise, we have to measure with the contact thermometer also. Whether the shaft is having same, the components are same, and our measuring devices are same. This is the first step. Before proceeding with the measurement, we have to ensure all are in the same temperature. Because micron level changes are happening due to the temperature variations also. This is the structure. Mounted. That's the mounted lagging. Because the components are already mounted in it. Then inner race is mounted, pinion is pushed, and finally, after the assembly time, you will be seeing the motor output will be like this. There is no important things there. Any doubts you can interfere. Anything, I have to repeat everything. Okay. That's what we see into the shaft portion. Because hopefully all the rotor having that inner race and all other things is there. These are all the steps for a rotor to revolve. Now we have prepared the rotor by mounting the inner race in its position. Now its counterpart is always there, a bearing. Whenever inner race is there, there will be an outer race. So this outer race has to also to be get exactly mounted as like the above said procedure. For example, we have a rotor beams, one is end frame driven and another frame is non-driven. Both ends are there. End frame driven, the structure of the end frame driven this is, end frame non-driven this is. As the same procedure, the outer bearing will get accommodated into this end frame. I will go to the next slide. The physical grade structure of the end frame, how it looks. Here we can see we have a board already. The board, previous shaft measurement we took only the micrometer and the body. We are prepared about body for the shaft. Now, being it is an end frame, we have to precisely measure the inner bore of the end frame. So now inner bore is set ready. This tabulation you can also see here. Now here the counterpart of this end frame is outer bearing. You can see outer bearing is 0.95960. Now the end frame ID. Here the process will be vice versa. Whenever it is a higher layer, when I am bringing and dropping a bearing, it will easily go inside. Then the question mark of interference will be nil like that. So here what is the concept is, this bore has to be less always than the outer bearing. Outer bearing should be bigger. Normally when I put, it should not go. Then how I can insert the bearing? There are many ways. Oscillating motors, if it is small tensions, we can specifically by nylon mallet you will get inserted. When it is a bigger motor like alternator, it has to be pushed through the hydraulic pressure will be applied for pushing the outer race. But here it is an intermediate pressure. In this, we have an option of heating the bearing bracket. When the bearing bracket is get heated with the induction heater, like 110 degree when we apply, just it will get heated, it will automatically get heated. When it reaches 110 or 120 degree, inner race will expand. The bearing when we come, after that if we drop the bearing will get heated. So bearing has gone inside. Then what will happen? We have to let this end frame and other assembly get it cooled down to the room temperature. When it cools down, it will automatically get contracted. So the required interference will be get. Getting the entire required interference, we have to arrive only to the mathematical calculation what we measure in the outer bearing, OD and initial lighting. So in that similar way, inner lapping also actually the lapping of IVs also. That is another component. Before putting a bearing, there is another lapping series there for the process center. So as far as the initial treatment is concerned, D side is also same, and D side is also same. That's what I didn't put there. Similarly, you can assume the same thing. Because readings are a little bit varying. The concept only we are discussing here. The concept is same for the bearing. Even though many components, sir, I have chosen this labyrinth. This is we can outer labyrinth. Outer labyrinth is the very important among all the, even though we make everything precise and everything, this outer labyrinth plays a vital role. Here it comes, now it comes the relation between the mechanical section and the TM section. Because this acts as a barrier between a traction motor, because in the earlier slide you can see traction motor is composed of a bearing inside. This outer labyrinth, this image, this slide. Now the motor is assembled, this is the outer labyrinth, this is the bearing. Back to this, we have a bearing. Bearing means the outer bearing, roller, grease, all other components are inside that. So now what comes the role? Whenever motor is running, there is a specific quantity of grease we have to input for the bearing. Like it is already predefined and mentioned quantity only to be given. So when motors are running, due to some external force, because grease tends to move away. Due to the centrifugal action, grease tends to move away. So when there is a tendency to move away, then there is no proper sealing to stop the moving grease. All the grease will come and flow inside the gear case. So finally what happens? The motor will be running with a lesser grease. The labyrinth is one such component that is designed, because the moving component we can directly put a seal. Labyrinth is the moving moving sealing ring, like that we can imagine. So the interior structure of the labyrinth is designed in this way, because I am putting here an unmodified version only that I specifically post, because you can see this component is getting engaged into, this is a non-moving component, this is a rotating component. Whenever I say rotating, the objects are in the shaft rotor. So whenever shaft rotates, this object will also start rotating. Shaft is rotated by means of the magnetic flux, it will start rotating. So these components also will rotate. Just assume this is a counterpart, it is engaged over here and it will rotate in this, just a micron or 300 micron gap, like that it is rotating. So this mechanism will not allow, because it has to pass through a resistance has been designed in that 1, 2, 3 gap is there, projection is there, the grease will be, now the inner race will be here, it has to come through, it has to pass through all the resistance, then only to come out of the motor. So this measurement and this fitment is very vital in traction motor, so that if it is loose, this component is also will get heated up and come out. So this measurement is also specifically given. How much gap? As I said earlier, 300 micron of gap will be available in this 250 gap, because that has to be ensured. Whenever it is lesser, it will get rubbed inside itself. When it started rubbing, then whenever the things is started rubbing, what will happen? Heat will be generated. Heat generates this object, the rotating object will get heat. Fixed object, the heat is generated, not an issue. When a rotating object gets heated up due to rubbing or something, obviously what will happen next? When a rotating object is getting heated up, what will happen next? Dimensional changes. Friction will result. Friction is resulting. It will generate a resulting heat. When the heat comes there, what is the role of heat to do with these objects? Expansion. When it gets expanded, then what technically what will happen? When it gets, already in early slides we have gone through interference slide. Then the matter what we strive hard for keeping the interference will all comes to the interference will expand, then there is zero interference. If there is zero interference, naturally it will not rotate all along with the rotor. Rotor will rotate at one speed, this will take its own speed, because it is simply we kept a bangle on the hand. Like that the scenario will be. Previously it is a gripped one, whenever it rotates, when it is expanded, it is like a bangle. So it will rotate and then further the accumulation of revolving, rubbing, friction, everything will generate, and finally overheat will happen and bearing seizure will happen naturally. This expansion theory is applicable not only for this labyrinth, inner race is also. Inner race is also subject to expansion. Inner is also subject. Inner side there is another term. Whatever, everything is naturally it will get expanded, but design has been taken care so that when expansion is happened, the shaft is also getting expanded. That also we have to take care. Not only heat is confined only for the rotating elements. The shaft is the bigger thing, it is carrying all the rotating elements. That also have a tendency to expand at one point of time. The grip will be always maintained. So that's what the interference range is given from this minimum to the maximum, considering the real-time working matters only that the interference has been given, the minimum and maximum. Maintaining interference on a higher side will be always a safer limit for us, because during the real-time scenario, what temperature is going and what expansion is happening may not be accurately we can't calculate. So safer side we have to go mid-range and above. That will always helpful for us to save the motor during these extreme conditions of heat conditions. So here it is mentioned 0.5 mm to 0.87 means the gap between. When one slot is getting inserted, then between the slots how much gap will be there? It's 0.5 minimum and 0.87 negative is given. So this has to be our perspective. Automatic gap combinations still we are already discussed. This is the way we have to measure the specific clearance, whether it is coming or not. It has to be accurately measured by means of this jig setup. Next, the videos will be covered in the upcoming sessions. Short activities has to be video coverage as our told. Because everything we can't memorize and then keep it theory. The videos are coming up, it will be very much familiar for everyone else. So these kind of videos also will be making. Finally, it's come up to the assembly. A motor in this way crosses many stages of bearing, fitment, clearances, combinational, and finally it is coming. Because we didn't discuss much about that part of bearing, because the bearing part itself is a very bigger subject. Finally, superficial things is there. Whenever a bearing it is said, the bearing is supplied to be designed with the 3 radial clearances. Clearance is the vital for any rotating parts has to sustain continuously run. Here we can, whenever new bearings are coming, if I put certain other slides will be much more better. Orally I am saying 3 radial clearances. 3 radial clearances is when assume a bearing will have outer bearing consists of rollers, and there is an inner bearing. You can say inner race. Whenever a bearing and inner race are kept aligned, there will be a gap. That gap is called the radial clearances. Why it is mentioned 3 radial clearances means it is free. Because free in the sense the outer bearing is not mounted in the end frame. As we discussed in the previous slide, outer bearing is not mounted in the end frame. Similar way, inner race is not mounted in the shaft. So both the components are said to be free. In this free condition, free radial clearances, the manufacturing end they have decided as per our audience recommendation. This has been told by manufacturer to manufacturer. Minimal a bearing can have a 0.170 and maximum a bearing can go for 0.220 mm. You can say micron, 170 micron and 220 micron should be the radial clearance, free radial clearance of the bearing. So, our side, whenever we receive a new bearing, this aspect we have to first check for the radial clearance of bearing is within the limit or not. Why it is important? We will come to the next discussion. The 3 clearances I have written here in the top, 3 radial clearances, 170 to 220 micron. I got a bearing. It is having this big clearance. Now interference in shield. Now I am taking the outer bearing and putting into the end shield. As per the previous procedure, I got one interference. Because the standard interference 10 to 25. I successfully mounted an outer bearing into the end frame. I got an interference of 10 micron. It's a case example for understanding. Then I am taking the inner race. Inner race I am going and mounting in the rotor shaft. As per the standard procedure, the 50 to 65 is minimum given, the range is given, I got a 50. Now we can, both the bearing components are fitted. Both got its own interference. From 10 to 50, 10 and 50 I am adding, we got a 60 micron. 60 micron of interference added. So it's a mathematical calculation. Not really we are not measuring what we are getting, just tabulating here. So already we know free bearing is 170 micron. Clearance is there. The interference we got. So I added it. Now final radial clearance what would be? That is a question mark. So through this calculation itself, we can conclude this motor when assembled. Coming to the final stage, we will have this clearance. How it is arrived means, 170 I have taken and I subtracted the total interference, now I got 110. So this is the arrival calculation based on the maths. We have arrived 110. Then it is kept as a kept aside. We have to keep this reading aside. Then we come to the reality what's happening, because always the mathematical and practical things and theory may not equate 100% exactly. So practically what is happening in this, because it's a micro level changes. So the motor is not assembled. The same motor is not assembled in this way. Finally, you can see previously clear how bearing can be checked for clearance between the roller and the inner race. What is the gap? There are methods are there. Filler gauge you can insert and check. The other way is we have to move using the dial gauges and check what is the clearances. Because visibly we have to see the components of the two mating elements is roller and inner race. Now you can see the motor is not assembled, and here we can't see anything roller. Then how we will conclude what is the clearance of this? There is only one mechanism. We have to play. We have to lift this pinion using a pressure. Here is a hydraulic mounted jack is there. When there is a clearance, this pinion will be little bit lifted. So I am pushing a pressure of pressure PSI. It will be slightly elevated. Small displacement will be there. The small displacement will be measured through this dial gauge. Dial gauge will give a small displacement. When I continuously pressing, the motor itself will lift. We can't go to that extent. When I put a small displacement, it will give an indication. So we will get a reading. The radial play after de-bearing, after pinion fixing. After pinion fixing, the only method to check the radial clearance is we have to measure the radial play. This is not the clearance. So radial play is being measured after pinion fixing by putting a dial at this 40 mm away from the outer lapping space using jack and dial gauge. So we will get one reading. What is the reading? From the dial gauge only we have to interpret. Dial gauge will detect and it will give some 130 in this range. Dial gauge will give one reading. Now that is not the real clearance. Okay. Finally, there is a tangential calculations are there, because this dial gauge is pointed at this location. It is not pointed at the bearing location. So here some this displacement happening means what will be the real displacement happen in the roller area. For that only this calculation is there. So radial clearance at the B side, and what we got is 130 multiplied by 0.86. You will get one reading among this. So finally, the practical reading what we got is, if we get comparison with this final years, then both will be matching with the tolerance of 5 micron to 6 micron plus or minus will be there. In that way, the reading is finally concluded and we are satisfying equally. Suppose why this calculation is not, suppose I am doing and I am not getting this 110. Instead of that it is going 80. Instead of that it is going 130. Then we have to either our calculation or pre-RC method is wrong, or something while doing assembling we have missed something or something wrong. So in that way, this is the final verification. Otherwise, if this activity, if it is not done, just assume our situation. We will do the bearing assembling, then we calculate this reading, everything will get in this range. We can say it is okay. But it is not like that. Based on the what we get, same only will be the output. So in that way, it has to be cross-verified. This is satisfactory. In many cases, we are dismantled and find some reasons also. So that is the final conclusion of this motor assembly. In spite of all our previous electrical and mechanical measurements and everything, finally this is a very important aspect to decide the motor has to be led for service or not. So this is the final thing of coming to the end slide. I think there are many more classes upcoming. Measurements means I declare there are many other measurements I skip in the sense measurements are vast and upcoming classes temperatures, phases and many other measurements are still there, but it's an outline. It has an outline of traction motor how it moves upon coming up to the text of its final shape.